Hey, this is Horner, and we're going to finish up this section, so we'll call this section 5 of everything you need to know about rotational motion to score a passing score. So you have a light string attached to a mass m is wrapped around a pulley of mass mp and radius r. So there's that. If the moment of inertia of the pulley is 1/2 mpr squared, find the acceleration of the mass. So one of the things that we need to do is let's go ahead and define that straight down is going to be positive. Now that we've done that, let's go ahead and draw a circle, and this circle represents the pulley. And we have several things we know about the pulley. We know the mass of the pulley times gravity is going straight down, and we know that going straight up, this little point on the pulley itself, the little piston, or really, I guess it's just the pivot point, there's a bar going through there, so there's a normal force that holds that up. And then we also have a radius, but in addition to that, we have a tension that is pointing down. And that tension is in a string, and it's equal to the tension on the mass that's holding, that's pulling down on that pulley. So here we've got the mass times gravity, and then going up for the box, we have tension. So these two tensions should be the same. This tension provides a torque on the wheel, and so what we're going to do is we're going to say the sum of the torques, so that's the sum of the torques, is equal to the moment of inertia times the angular acceleration of that pulley. So let's try to figure out what is the torque then that is on this pulley. Well, there's only one torque, and it's going to be the tension times the radius, and so we're going to say that the radius is capital R here. And that is equal to I, and we said I is 1/2 of the mass of the pulley times the radius squared, and we're going to multiply that times alpha. Okay, so now that we've done that, we can cross off one of our r's, so there's one r gone, and we also know that alpha is equal to a over r, so we're going to plug that a over r into this section, and when we do that, we're going to be left with this equation. T is equal to 1/2 of the mass of the pulley, and then notice that the r's cross off, and I'm left with just a. So far we've done the tension that's coming from the pulley. Now we need to turn around and look at the tension that's coming from the box. So the box has the sum of the forces on it, and it will accelerate ma. So here the pulley accelerates with I alpha, and the box accelerates with ma. So here we go. We know that going down is positive, so mg is the thing that is going in the down direction, minus t, which is going up, and that's equal to ma. We can go ahead and we know that we said that t here is equal to 1/2 mpa, so we're going to do mg minus 1/2 the mass of the pulley times the acceleration, and that's equal to the mass times the acceleration of the box. So where we don't have any labels on the m, that is the mass of the box, or we have the label mp, that is the mass of the pulley. So at this point what we'll do is we'll go ahead and say mg is equal to ma, and then we're going to add this to the other side, so that's plus 1/2 the mass of the pulley times the acceleration, and we want to now factor out this a. So now we're going to have mg is equal to a times m plus mp over 2, which is the same thing as 1/2 mp. Now let's solve for a. So a is equal to mg over m plus mp over 2. And we've done what they want. They want us to find the acceleration. There's no numbers, so we can only do it in letters. And so that is your answer to number 31. Let's go ahead and take a look at the next one. This is by far the most difficult one that you'll probably have to do. And this one kind of goes this way. Let's move this down a little bit. We have two blocks. They are connected by a light string, which means that we don't have to worry about the mass of the string, over a pulley mass MP and a radius R as shown in the diagram. One of the things we're going to do is we're going to change that M right there to mass 1. So, and then we're going to change the other one to mass number 2. that will make it make a lot more sense. If we left them the other way, it'd be a little bit more difficult to keep track of all our numbers. So let's start by doing a box for, oops, I guess I need to switch to something other than white here. Let's do a box for M1. So this is going to be straight down is M1G. Going up for this one is the normal force, since there's a surface here, contact force. And then going to the right is tension number 1. For this box, box 2, we have going straight down is M2G, and going straight up is T2. T1 is not equal to T2, and the reason is because we have a pulley now that does have mass. So we're going to draw a free body diagram for it also. Straight down for the pulley is the mass of the pulley times gravity. Coming up in this direction, coming from this little bar here, is the force of the pulley. And then we've got two tensions. So we have a tension going this way, which is T2, and that points down towards the box, so that's this right here. And then we also have T1, so here's T1. So now we've got 3 different diagrams. They all tell about what's going on. So let's start with our first one. Let's find out what are the sum of the forces, and we're going to do the sum of the forces in the x direction for this one. Sum of the forces in the x direction are going to be equal to m1a, because I know that this thing is going to accelerate to the right. And the only thing that I have in the x direction is just tension. There's no friction here. So this is tension 1 is equal to m1a. So that was pretty easy. Let's do the same thing for this diagram. Sum of the forces, but this time it's in the y direction for this one, and that is going to be equal to m2a. Let's go ahead and say that the down direction is positive for what we're doing here. And if we do that, we can say m2g, that comes from this one, minus t2 is equal to m2a. So notice we can't just plug in this t1 into the t2. It doesn't work that way. We're going to have to use this equation, but let's go ahead and solve it for t2. So t2 here is going to equal m2g minus m2a. So you have to work through. Notice that the T2 here is negative, so I moved it to the right, and then I moved the M2A to the left, and that's why you see what you do. The last thing we need to do is we need to figure out for this pulley system, what are the sum of the torques? So here the sum of the torques are equal to the tension number 2, since it's going in the positive direction, so tension number 2 times the radius minus tension number 1 times the radius. So there's tension number 1 times the radius. So remember, if this is a force times a radius, so that's a torque, minus this torque going to the left should be equal to I times alpha. Now what we're going to do is we're going to use this equation, and I'm going to actually switch colors here. We're going to take this equation and we're going to flesh it out right here. So let's start with T2 times R. T2 from what we had here is this guy. So this is M2G minus M2A, and then we're going to multiply that times the radius of that pulley. Minus, now we're going to do this term right here. We have T1, which is M1A, and then we take that times R. If we factor out the R here, we'll have R times M2G minus M2A minus M1A. And then on the other side, we've got I alpha. So we need to write down what I is. So I here for this pulley is the same as it was in the last one. It's just 1/2 mass of the pulley times the radius squared. And then we need to multiply that times alpha. But remember here, alpha is equal to A over R, so we're going to plug the A over R in for alpha and get rid of alpha. So let's do that. If we do that, this is 1/2 of MP R squared times A over R. All right, so we've got a lot going on. We've got an R on this side, we have an R squared on the top and an R on the bottom. So if we get rid of the R squared and get rid of that R, we can then also have that R and this R cross off. So now we've eliminated all the r's. Let's go ahead and write out our equation. This one's going to be m2g minus m2a minus m1a is equal to 1/2 mass of the pulley times a. They want us to solve this for a, so we need to get all the a's on one side. To do that, let's take these two and move them to the other side. We'll add them to the other side. So now we've got m2g is equal to 1/2 mpa plus m2a plus m1a. Now at this point what we can do is factor out an a, so we would have m2g is equal to a times 1/2 mp plus m2 plus m1, and now we're just going to solve for a. We'll divide both sides. So if we do that, we're going to end up with m2g on the top, and then on the bottom we're going to have mp over 2 plus m2 plus m1. And that is our final solution for number 32. And at this point, we'll stop and we'll move on to the next section in the next video.